Hello everyone, I am Shehroz Faruqi and I'll be presenting our work CanaryTrap, detecting data misuse by third-party apps on online social networks. This work is a joint collaboration between University of Iowa and Lahore University of Management Sciences. So there have been several high-profile incidents of data misuse on popular online social networks. One of the most notable incidents is Cambridge Analytica, where data of more than 50 million Facebook profiles is harvested in a major data breach. This data was allegedly used for user profiling during 2016 US presidential elections. Now, among all these disparate cases of data misuse, the one common denominator are the third-party apps. The data in these cases has been extracted by a third-party app, which was later exposed or misused. For example, Cambridge Analytica used a third-party personality quiz app. This is your digital life to harvest millions of users' profiles. So, how does the ecosystem of third-party apps work? Now, popular online social networks like Facebook, Twitter, and Instagram provide development platforms. These platforms enable third-party developers to create apps. For example, it allows developers to build games or integrate authentication to their websites. There are many popular developers like Candy Crush Saga, Spotify, NameTest.com who got millions of Facebook users who have installed their app. Now, once a user installs a third-party app, the app can access users' personal data through development APIs, depending on the permissions that were granted by the user at the time of installation. Now, an app can ask for various kinds of permissions like email address, phone number, date of birth, location, check-ins, or other activities of user. Now, this information can be used for building meaningful apps by honest developers. However, it also opens up large possibilities of a potential misuse of user data retrieved by a third-party app. To further elaborate how an app can retrieve user data, which can be later misused, I'll discuss an example. Let's say there's a Facebook user account who has its profile information like email address and date of birth. Now, the user installs a third-party app and gave it permission to access this user data. This third-party app is going to use Facebook's Graph API to retrieve user data. Now, this app can install, can save this data on its servers. This third-party app can use this data for implementing various functionalities like building user registration, filling up their registration details using user profile information. However, an attacker can obtain data through a data breach, or a dishonest developer may sell or share this data to an attacker, who could be a data broker, advertiser, or a partner website. The attacker can then misuse this data in various ways. For example, attacker can send spam emails or use it to display targeted advertisements. This data can be even used for profiling during elections, as discussed earlier. Now, to curb data misuse by third-party apps, there has been some prior work to investigate data leakage by third-party apps on the client side, such as browsers. For example, Hubbard et al. Investigated an app by installing it in a dummy Facebook account and then looked for any data that has been leaked to any advertiser or tracker or another server on the app's website. However, the problem with this approach is that it cannot tell whether or not the leaked data has been misused or was it just accidentally being leaked. And secondly, we cannot tell whether or not any sharing or misuse of the data has occurred on the server side. On the other hand, online social networks also have limited options in practice. For instance, they can detect excessive or anomalous API access patterns by third-party apps to retrieve user data. While this information tells how much access to data a third party may have, it cannot tell how much user data, it cannot tell whether data has been misused or not. Now, to restrict the use of data that has been accessed by a third-party app, online social networks can mandate developers to certify compliance to their terms of services. However, a dishonest developer can simply lie. For example, Cambridge Analytica lied that they have deleted user data, but actually they did not. In summary, the key challenge in detecting data misuse by third-party apps is that neither online social networks nor user has any control over the use of data once it has been retrieved by a third-party app and stored on its server. Thus, in our work, we focus on devising an approach to detect data misuse by third-party apps. Here is an agenda for the rest of my presentation. First, I will present our proposed approach CanaryTrap to detect data misuse by third-party apps. Then I'll discuss results of our deployment of CanaryTrap on Facebook. I'll also present a matrix variant of CanaryTrap that can enable independent auditors to implement CanaryTrap on a large scale. Finally, I'll report our results of enforcement of existing developer policies by Facebook. Our results actually showed a lack of enforcement uh, by Facebook here. So starting off with CanaryTrap. So CanaryTrap uses a honey token based approach to detect data misuse by third-party apps. A honey token refers to a piece of information such as email address or date of birth that can be intentionally leaked or shared to detect its unrecognized use. On a high level, CanaryTrap has two components. First, sharing a honey token with third-party app and then detecting misuse of this honey token via monitoring channels. So let's take an example of honey token email as email address. Now we detect its misuse by looking at the emails received on the email accounts of this email address. If we receive an email from any entity which is not third-party app, we say that our honey token has been potentially misused. We can also use other monitoring channels like data broker APIs or ad transparency tools, which takes email as input. Next, I'll give a detailed overview of our CanaryTrap's implementation using email as a honey token and received email as a monitoring channel. Now, first we create, so starting off with how we share a honey token with third-party app, first we create a user account on an online social network. We then assign an email address as a honey token to the user account. Then we install the third-party app that we want to monitor, and then the third-party app request API to create email address. Now we use received emails on the email account of the shared email address as monitoring channel. We pass each retrieved email through a keyword matching process that determines whether an email is sent by a third-party app or an unrecognized entity. Now, each email is either either labeled as recognized or unrecognized. This keyword matching process generates keywords of an app full name and its website. And then they search these keywords in the email's header field, like reply to and from to field. If the email is matched with the third-party app, then we say that the input email is recognized, otherwise it is unrecognized. Let's go through an example of detecting a recognized and unrecognized email by plugging both these components together. Let's say a third-party app sends itself an email on the email accounts of the shared honey token. When we pass it through the keyword matching process, it is recognized. Now, let's say a third-party app sells our data or share it with another entity. Now, if that entity, which is an attacker, could be an attacker, sends us an email, it will be unrecognized. Now, we analyze the content of these unrecognized emails. If the content is not related to the app, then we conclude that the user data shared with the third-party app has been potentially misused. Now we explain an implementation of CanaryTrap. We will next discuss our deployment on Facebook. So firstly, why we deploy on Facebook? One of the reasons is that FTC has imposed several restrictions on Facebook after several cases of data misuse. These restrictions include a greater oversight of third-party apps as well. We believe that our deployment of CanaryTrap on Facebook could also help us build an idea whether data misuse is still present on Facebook or not. For monitoring, we select 1024 third-party apps on Facebook that request email address, since email address is our honey token. These apps are integrated on top 1 million Alexa websites. Then we automated the workflow of sharing email address as a honey token with these third-party apps. First, we create a Facebook account, then we set up our own email server. This allows us to create unlimited email addresses. We use a database of common names to create email addresses. Finally, we use Python and Selenium to automate the entire process of opening the host website of a third-party app and installing it. We also make sure that an app is removed from the Facebook account before we assign a new email address to the Facebook account. This allows us to maintain a unique one-to-one mapping between an email address and a third-party app. We installed all these apps during December 2018 and January 2019. As monitoring channels, we use received emails and Facebook's ad transparency tool. Now, this Facebook's ad transparency tool allows us to see the list of advertisers who uploaded our email address for targeted advertisement. In the best interest of time, I will only report the results of received emails and encourage everyone to check out our paper for reading more detailed results on Facebook's ad transparency tool. So we monitored emails for over a period of 1 year. We use a catch-all email account that acts as a control to eliminate any random noise. In total, we received 12,704 emails. We labeled these emails using keyword matching, and we and 353 emails were labeled as unrecognized, which were received on the honey tokens shared with 16 apps. So then to better understand the severity of misuse of our honey token, we manually analyze the content of these 353 unrecognized emails. As I discuss next, we label each of these emails as either malicious, unrelated, or functional. We label an email as malicious if we find that the content of an email is clearly a spam or a scam. The email accounts of honey tokens shared with three apps received malicious emails. So this figure displays all these three cases. These red crosses indicates an unrecognized email, while these green dots indicates a recognized email. And these emails were received over the period of 15 months as shown in the x-axis in the figure. So these are the most egregious cases of data misuse. In a study, since data has been potentially obtained by spammer or scammers. For example, we received the ransomware scam email where an attacker claims to hack our computer and asking us to pay $754 in Bitcoins. We actually found anecdotal evidences that the database of two out of these three apps websites were breached during our monitoring time period. So next we label an email as unrelated if the content of the email is not related to the app, which could potentially be spam. Some examples of unrelated content include promotional offers and links to products from unrecognized centers. So email accounts of honey tokens shared with 9 apps received unrelated emails. So in the first 4 highlighted cases, we could not find any connection between the unrecognized entity who sent us unrelated emails and the third-party apps. So possibly there was some secret data sharing deals going on by which our data was shared. In the bottom 5 cases, we actually did find a relationship, and they were in some cases partner or affiliate websites. Nonetheless, in all these cases, are potential violations of Facebook's TOS, which prevents developers from sharing data with any other unknown entities. Also, developers, some of these third-party apps are actually popular host websites. For example, this Tom Hardware Guide IT Pro website is ranked in top 1500 on Alexa and has estimated over 10 million monthly unique visitors. Finally, we label an email as functional if the content of the email is related to the app. We found that email accounts of 4 apps received emails with functional content. In these cases, however, we found that apps are actually just using email servers or authentication system from unrecognized entities, and thus we do not call this a data misuse. So a deployment of CanaryTrap has shown that CanaryTrap can uncover misuse of user data. Now we propose a matrix variant of CanaryTrap that can allow large-scale implementation of CanaryTrap. So first, it is like online social networks, firstly, are in the most comfortable position to deploy CanaryTrap. But what if an independent auditor or a regulator like FTC wants to deploy? So based on our experience, we face a lot of restrictions from Facebook's existing abuse detection systems. Actually, when we were rotating email addresses frequently, Facebook temporarily locked our account. So as an alternate, what we can do is we can create a large number of Facebook accounts. However, the problem is that Facebook is actually very good at preventing us from creating a large number of accounts as well. So one possible solution is to monitor a large number of apps would be to somehow reuse a single honey token to monitor multiple apps. Thus, we propose a matrix variant of CanaryTrap that allows reusing a honey token to monitor multiple apps. So we can monitor m into n apps using m plus n honey tokens, which means we can monitor a million apps by just using 2,000 honey tokens. The next challenge is that how do we tell in case an unrecognized email comes, who is the app responsible behind sending this email if we have leaked it to leak one honey token to multiple apps. So in the matrix variant, honey tokens are shared with a specific arrangement, such that while one honey token is shared with multiple apps, each app is shared exactly with two honey tokens. Each app is shared exactly two honey tokens. Now to elaborate this arrangement, let's consider this example. There are 16 apps we want to monitor placed in a matrix grid of 4 by 4. Now we share honey token 1 with 4 apps in the first row. Similarly, we share honey token 2, 3, and 4 to apps in the corresponding rows. Now to share exactly 2 honey tokens with each app, we share honey token 5 with apps in the first column of the grid. Then similarly, we share honey token 6, 7, and 8 apps, 7 and 8 with apps in the corresponding columns. Now, intuitively, if an app sends an email to all its users, then we should receive email on both honey tokens shared with the app. That is, one in the corresponding row and the other in the corresponding column. Now, let's say the email accounts of the honey token 1 and honey token 7 receives an email from a same sender. Then we attribute both these emails to app 3. Now, what if this app 3 leaks our data to an attacker and then attacker sends an email? Then we can detect that app 3 was responsible behind the misuse of our data. So we deployed matrix variant of CanaryTrap to monitor same 1024 apps on Facebook. Note that we call the previous deployment to monitor Facebook apps as array variant, since honey tokens are shared with apps in a linear way. We evaluated the accuracy of the matrix variant by deploying it alongside the array variant as ground truth. Overall, we find that the matrix variant is able to detect 9 out of the 16 cases detected by the array variant. While the matrix variant can monitor more apps using fewer honey tokens, it is prone to mistakes. For an in-depth analysis of these mistakes and mitigation ideas, I encourage you to check out the paper. So in the final part of my presentation, I'll present results of evaluating enforcement of existing developer policy by Facebook. We evaluate enforcement of multiple policies by Facebook in the paper, but for the sake of presentation, I'll only focus on one particular policy here. This Facebook's developer policy requires a developer to delete data of user retrieved using third-party app if a user requests. This gives user an opportunity to curb potential misuse of user data by apps. To determine whether or not developer comply with Facebook's policy, we sampled 100 Facebook apps that we previously monitored, and then we requested them to delete our user data. Our result once again showed a lack of compliance by developers. Roughly half of them contacted developers to not even respond. More surprising result is that 13 apps even continue sending emails despite acknowledging that they have deleted user data. These results are alarming and raises concerns over Facebook's enforcement of their existing developer policies. So we have also launched a public disclosure page that shares details of apps that are detected as misusing user data or violating Facebook's developer policy. We have also disclosed our findings to FTC, who have responded that they are looking into our results. We also disclosed our findings to Facebook in the last week of June through Facebook's data abuse bug bounty programs. Facebook is currently reviewing the findings of our paper. After our disclosure, Facebook announced to limit the information that third-party developers can share with data with other entities, and they've also tightened the requirements for developers to delete user data. After our disclosure, an app developer emailed us that they had no idea what their app even does so they have activated it right away. This shows that it is not just Facebook, but unfortunately, sometimes app developers are also often clueless. So overall, our results demonstrate a lack of enforcement by Facebook. Many of the apps detected by CanaryTrap that misuse user data or fail to honor user data deletion requests are still functional. Thus, more proactive monitoring of third-party apps is required by Facebook for detecting misuse of user data in compliance of their existing developer policies. There is more future work that can be done to enhance future implementations of CanaryTrap. Similar to matrix variant, we can further reduce the number of required honey tokens by using a higher dimensional tensor framework. However, more future research is needed to make these higher dimensional frameworks robust to mistakes. Future implementations of CanaryTrap can also explore other profile attributes such as location, gender, and date of birth as honey tokens. However, more future work is needed to build sound monitoring channels to detect misuse through these honey tokens. Last but not the least, CanaryTrap can be readily implemented with slight modifications on other platforms such as Twitter, Instagram, Snapchat, and Google. I will be happy to engage and talk more with these platforms. I will also be happy to engage with regulators like FTC for independently auditing third-party apps on these platforms. Feel free to reach out to me for any questions and future collaborations. With this, I conclude my presentation and will be happy to take any questions.